In this video, we're going to go over the AP Calculus AB free response question number 1 from 1999. Part A wants to know if the particle is moving up or down at t equals 1.5. And since we're given velocity, we know that a positive velocity versus a negative velocity will tell us which direction we're moving. And since it's along the y-axis, a positive velocity would be up and a negative velocity would be down. So we just need to say, okay, what is v of 1.5? And if you plug that into your calculator, you're going to get about 1.167. And so then we would say up because v of 1.5 is greater than 0. That's A. Part B. Acceleration at t equals 1.5. Well, A of t is just v prime of t. And you could do the derivative of v here using your or by hand rather. You would need product rule and then chain rule with this t squared here. Or because again this is a calculator allowed, there's no way we're getting that 1.167 without a calculator, we can just find that value on our calculator. And so v prime of 1.5 is about negative 2.048. And so the velocity, because acceleration is negative, because the derivative of velocity is negative, that means the velocity is decreasing. So we would say velocity is decreasing at t equals 1.5 because v prime of 1.5 is negative. It doesn't matter what quantity you're talking about. If you want to know whether something is increasing or decreasing, you're almost always going to answer that question by finding the derivative and seeing whether the derivative is positive or negative. So in this case, velocity is decreasing because its derivative is negative. All right. I'm going to get all that stuff out of the way, so if you need to pause the video before I get rid of all that, go ahead and do that. All right, so then in part C, we want to know the position at time 2. So it says y of t is the position, and we want to find y of 2. So in general, if we're given a velocity function, which we are, and asked for the position, we know that my position will always equal, let's say, position at t equals b will always equal, so p of b will always equal the integral from a to b of v of t plus p of a. Oops. Sorry, clicked the wrong thing there. This is my initial position. This represents my displacement or my net change, how much my position has changed. So if I know where I am at A and I know how much I've changed from A to B, well then I know where I am at B. So we just plug that stuff in and change our letters, right? So this time we want y of 2 is going to be the integral from 0 to 2 of v of t dt plus y of 0. Y of 0 is given to me as 3. And then just figure out what this piece what this definite integral is here, and I think that it is 0.826. And so then y of 2 is 3.826. So hopefully not too bad. And then in part D, we want to switch to the total distance traveled. And remember, this integral here is the displacement. There's a possibility that between 0 and 2, maybe I was at some point way out at like 7, and then I came backwards and ended up at 3.826. Started at 3, went way forward, and then came back, perhaps. So we just have to figure that out. Now, there's two ways to do that, and I'll look at both of them. So once again, I'm going to clear all this out of here, so go ahead and pause if you need to. All right, so there's two ways to do this. The simplest, most straightforward way, since we have a calculator, is to say that distance traveled, total distance traveled, I should say, is always the integral of the speed function, which is the absolute value of the velocity function. And so I can just do that on my calculator. And if I do that on my calculator, I get about 1.173. Now, just because it's good to review, if I didn't think about using that absolute value, or if this was a different question with a slightly friendlier function and not a calculator, what I would do is I would have to split this up and say, okay, where, if I were to graph my velocity function, where does this change sign? Is there anywhere where this is, in fact, negative? And so the way that I would, and again, I would somehow figure that out. If it's no calculator, then it's got to be something that I can solve by hand, which actually in this case, I can do this. So I could actually solve this and say, okay, set velocity equal to 0. Figure out where that happens. Well, I set both of these equal to 0. That gives me t equals 0. Okay, not interesting because we're starting at 0. And then 0 equals sine of t squared. If I solve that, well, I have to take inverse sine, and sine is 0 at 0 and pi, and all those integer multiples of pi. But because I have to only be within 0 and 2, there's not that many of these possible solutions, because I'm going to get the first solution is pi is equal to t squared, and then I have to square root that. And if I square root that, well, I'm just going to call that the square root of pi. Oh, that's not approximate, that's equals. And that's already, well, if you look at 2 pi, then you're going to be beyond 2 at that point, so we're not interested in that. And then you just split up into different intervals. So you would do the absolute value of the integral from 0 to root pi of v of t dt plus the absolute value of the integral from root pi to to 2 of v of t dt. That way, what we've done is we've said, okay, anywhere where there might have been some positive velocity and then some negative velocity, those can no longer cancel each other out because we've done these individual absolute values, and thus everything is positive. It has the same effect as this one here. What people will sometimes do by mistake is they'll put the absolute value on the outside here, and that doesn't do anything. It just makes sure that your displacement is positive, which doesn't help because the positives and negatives of the area have already canceled themselves out if you don't have the absolute values in here. All right. That is all for this one.